When you think about Albert Einstein in his later years, what's the first thing that pops into your head? For a lot of us, it's this image of a genius, right? But a genius who was stubbornly fighting against the weird new world of quantum mechanics. The story we're all told is that the father of relativity, well, he just couldn't keep up. But is that what really happened? This quote right here from Einstein's own biographer, Abraham Pais, pretty much sums up the popular myth. The whole idea is that Niels Bohr, who is the big champion of quantum theory, was just so far ahead that arguing with Einstein was kind of pointless. It makes Einstein sound like an old relic, lost in a universe he didn't understand anymore. Okay, so let's get into it, because the truth is, it's not a story about failure at all. It's a story of this incredible and, as it turns out, prophetic insight. Einstein wasn't out to lunch. He was asking questions that were so deep, so fundamental, it took the entire world of physics about 50 years just to catch up. So the story you usually hear is pretty simple, right? After his mind-blowing work on relativity, Einstein supposedly spent the rest of his life trying to poke holes in a theory he just didn't get. He's painted as this old-school conservative, clinging to this neat, clockwork vision of the universe, while all the young physicists were diving into the wild, probabilistic world of the quantum. But here's the twist. To really understand why Einstein was arguing, you have to get one thing straight. He wasn't some outsider looking in. He was one of the guys who built the house. He laid some of the most important cornerstones of the very theory he would later spend so much time questioning. And just look at this timeline. It shows just how deep in it he was. It's so easy to forget that back in 1905, and get this, the exact same year he published on special relativity, he's the one who proposed that light comes in these little packets, these quanta. That's the photon. That's literally the bedrock of quantum theory. And he didn't stop there. He applied quantum ideas to solids, he introduced probability with his work on stimulated emission, which, by the way, is the science that makes lasers work, and he even got behind the super strange idea of wave-particle duality. So no, he wasn't just a critic, he was a full-on leader of the quantum revolution. So if he was one of the founders, why the big fight? What was all the fuss about? Well, because his famous debate with Niels Bohr wasn't really about the math. Everyone agreed the math worked. It made fantastic predictions. No, their fight was about something way, way bigger. It was a clash over the nature of reality itself. This slide just lays it out perfectly. On one side, you've got Einstein. He believed in what he called objective reality. Basically, the moon is there and it has a specific position even when nobody's looking at it. And the whole point of physics for him was to describe that reality. But on the other side, you've got Bohr. And Bohr argued that things like position don't even exist until you measure them. The universe is just this fuzzy cloud of possibilities, and our act of looking at it, well, that forces it to pick one. To Einstein, this was just nuts. He famously asked, does the moon only exist when a mouse looks at it? And this core belief of Einstein's, it has a name, realism. It's this gut-level feeling that the universe is out there with real properties, just waiting for us to discover them, not for us to create them with our experiments. For him, this was the absolute philosophical line in the sand he just would not cross. So, to prove his point, Einstein and a couple of colleagues came up with this brilliant thought experiment in 1935. It's called the EPR paradox, and it was designed to show just how absurd the Copenhagen interpretation was. The implication of it was something he called, and I love this, spookhoofde Fernbrücking, or spooky action at a distance. The logic in that paper was basically a perfect trap. So, picture two particles that are linked together, then they fly apart. If you measure something about one of them, you instantly know the same thing about the other one, even if it's light years away. So Einstein said, look, this leaves us with only two choices. Option one, maybe those properties were real the whole time, and quantum theory is just incomplete because it doesn't describe them. Or option two, information is zipping between these particles faster than the speed of light, which would make the universe non-local. And for Einstein, the guy who proved nothing can go faster than light, that was a complete deal breaker. But here's a little behind-the-scenes drama. Einstein was actually really frustrated with how the paper turned out. He felt his co-author had kind of smothered the beautiful, clear physical point under this huge pile of complicated math. He wanted to show a real-world contradiction, not just give people a math puzzle to solve. And because it was so complex and because Einstein already had this rep as a quantum skeptic, the physics world just kind of shrugged. They basically said, huh, that's interesting, and filed it away as a philosophical conundrum, something you could talk about over coffee, but not a real physical challenge to the theory. So for decades, Einstein's deepest, most powerful objection was just sitting on a shelf, labeled philosophy. And that's where it sat for almost 30 years. Until the 1960s, when this Irish physicist, John Stuart Bell, came along. And he looked at Einstein's philosophical question and realized something incredible. You could actually test it in a lab. And just like that, Bell changed the entire game. He took Einstein's thought experiment and turned it into a real testable prediction. You can see the whole journey here. Step 1, Einstein poses the challenge. Step 2, everybody ignores it as philosophy. Then, boom, decades later, step 3, Bell creates a real-world test. And then, step 4, the experiments get run and the results were absolutely mind-blowing. They prove that reality is as spooky as quantum mechanics says it is. Spooky action is real. So yeah, Einstein technically lost the debate. But here's the crazy part. He won by losing. He asked a question so powerful and so right that it forced physics to look in the mirror and confront how truly bizarre our universe actually is. And now we get to the ultimate irony of this whole story. That spooky action at a distance, the very thing Einstein hated, the thing he thought was a flaw in the theory, it turns out it's not a flaw. It's one of the most powerful resources we've ever discovered, and it's fueling a whole new technological revolution right now. I mean, look at this list. The quantum entanglement that bothered Einstein so much. It's the engine behind quantum computing, which could solve problems our most powerful supercomputers couldn't even dream of. It's the key to quantum cryptography, which means truly unhackable communication. It's even the basis for quantum teleportation. The thing Einstein thought was a bug, well, it turned out to be the most incredible feature. So no, Einstein's long fight with quantum theory was not a failure to understand. It was the complete opposite. He saw the strange, reality-bending consequences of the theory more clearly than anyone else. He refused to just, shut up and calculate, as the saying goes. He made the world look at the deep, philosophical weirdness at the very heart of reality. In the end, sure, Einstein lost the argument with Bohr, but his questions are what shaped the future of physics. And it really makes you wonder, doesn't it? What profound, seemingly philosophical question are we all just dismissing today that might just hold the key to the next scientific revolution?